First question, 7b, relies on these formulas throughout 7b. Make sure you identify which one. Is it angular speed, or is it speed, the W or the V? First, we have a piece of light inextensible string, 2 meters long. One end is fixed to a point on a smooth horizontal table. Let's have it here. And the other end is tied to a mass of 8 kilograms. So let's have the 8 kilogram mass on the left here. So we have 8g going down. We know the force, the centripetal force going towards the center, are the two formulas above. The speed of the particle, so we're given v, so we're going to be using the second one here, is 5. V is equal to 5. Find the tension in the string. So we have the tension going towards the center, and the tension going towards the center is going to be equal to mv squared over r. So T is equal to m, which is 8, times v squared, which is 5 squared over the radius, and the radius is 2, the length of the string here. No triangle diagram in this one. 2, so that's going to be equal to 8 times 25, 200 over 2, which is 100 newtons. Just a nice easy start before we get into the more complicated ones. In question 2, the string is 1/8 meters long, so 0.125 meters, 1/8. And we have the same diagram. Again, we have the radius will be 0.125. The mass is 7 kilograms. I'll put in the 7g. We don't need it in this question. It's on the table, and it's going around in a circle around the center point, like this, in this direction. And we have the angular speed here. We have W is 4. W is equal to 4, and the radius is 0.125. So the formula required here, the force, the centripetal force in this case going towards the center, is m W squared, or, so that's going to be equal to the mass, which is 7, by the angular speed squared, by the radius, which is 0.125, or an 8. Might be easier to see it as an 8. So we have 16 divided by 8 is 2, times the 7, which will give us 14 newtons for the tension in the string, which is going in this direction, which is the same as the centripetal force. Question 3, we have the string of length 5 attached at one end to a fixed point P. Okay, let's have P here. And it's 4 meters above the horizontal table, so let's have this direction here being the length of the string, which is 5. P is 4 meters above a smooth horizontal table, so this is 4. This one here by Pythagoras will be 3, as you already know. We'll do all these diagrams the same. We have A, we have tension in the string directed towards the center, T. So cos A will be equal to 3 over 5, this direction here. In terms of T, this will be T cos A, which will be equal to 3t over 5 for my force in this direction. Sin A across here is 4 over 5, and T sin A in terms of T will be 4t over 5. So that's my direction going up. Coming down in this direction, we have the weight of the mass of the kilogram, 5 kilograms, so 5g, which is 49 newtons. We also have the reaction at the table going up. So what are our forces here? Let's start up here. So we have R plus, what else is going up? This one here, 40 over 5 is equal to what's going down, which is 49. So we have two unknowns. So let's focus on this direction, which is my 3t over 5, has to be equal to mv squared over r. Just keep jotting them down and you'll get used to them. Or m angular speed squared r. So what have we got here? We have speed, so we're using the one with v in it. Speed is 3, so we have m, which is 5, times v squared, which is 3 squared, over the radius, which is also the radius of motion here, 3. So 3t over 5 will be equal to 5 3's 15. So 3t will be equal to 75. That's where the 3 is coming from. So tension in the string is 25 newtons. So we go back up to my or plus 4 over 5 times t, 4 over 5 by 25 will be equal to 49. So 5 into 5 goes, 25 goes 5 times, so or plus 20 is 49 newtons. So or is going to be 29 newtons in this case, the normal reaction at the table. We found the tension in the string, and the radius by Pythagoras is this 3 that we started with here. Maybe show your square root of 5 squared minus 4 squared if you're doing it in an exam is equal to 3 at the very beginning for question 3. In question 4, the string's length is 5 root 2 meters, and it's again fixed to a point P, which is 5 meters above a table. So we have P up here. We have the length of the string is 5 root 2. To get the radius of motion, we'll use Pythagoras. We have 5 meters here. So this side here, the square root of 5 root 2, all to be squared, bracket it, minus 5 squared. You may see that's going to give 25 by 250 minus 5, 25, which the square root of will be also 5. And we put our angle in A, it's going to be 45 degrees if these are both 5. So the angle which the string makes with the table, that's what we're asked. So 45, you could say the tan of A is equal to 5 over 5 or 1. Therefore A is equal to the inverse tan of 1, which is 45 degrees. Tension in the string. Okay, let's have a look at tension. So what are my forces coming down? So we have 10 kilograms, so 10g here, which is 98. Just jot that down here. Going down, we have 98 newtons. We have, I'll extend it up a little bit, the normal reaction. And we also have over this side, in terms of t, we have, I'll do the cos of A and the sine of A. The cos of A is equal to 5 over 5 root 2, which is equal to 1 over root 2. So in terms of t, t cos A is equal to t over root 2, and the sine will be the same. T sine A is also t over root 2. So going up in this direction, we have t over root 2. Coming down, we have 98. And going up, we have or. And in this direction, we have centripetal force. We have the speed in radians, the angular speed. So we have W. So we're going to use mw squared or. That's going to be equal to t over root 2. That's all that's going in that direction. So the mass is 10 by the angular speed, which is 1 squared, by the radius, which is the 5 that we worked out down here at the beginning, is equal to t over root 2. The left hand side is going to give 50, so 50 root 2 is equal to the tension. And the reaction at the table, well, we have this formula here, or plus t over root 2 is equal to what's going down, force up equals force down. So t divided by root 2, well, if I just come up here and do a little bit of rough work, if I divide this by root 2, t over root 2 is 50. So we're going to get or plus 50 is equal to 98. So therefore or is equal to 48 newtons. And that completes question 4.